I'm Jacob Pardue, and I am the group reporter for the Vapor Compression Refrigeration Heat Pump. Quite a lengthy name. So, as Dan just pointed out, there's a few goals I'm going to remind you guys about. One of them is to learn how to measure the coefficient of performance, and the other is to describe the vapor compression refrigeration cycle on a pH diagram. And some of the theory behind it is the coefficient of thermal performance, which is defined as the desired commodity over the power that you have consumed in the process. And it's calculated directly from enthalpy. This is our rig that we're using. Just a few of the main components is the compressor, which is at 1 here, and the compressor. I don't know why compressor's on there twice. Should be compressor, and then, condenser, and then evaporator, sorry about that. So 2 is the condenser, 3 is the evaporator, 4 is the water reservoir, and the 2 heat pumps that you adjust the valves on for flow rates. So the procedure was, we started the software, we opened it and open the evaporator and the condenser valves. Then we set the water flow rate to 5 liters per minute, switched on the compressor, and let the system become stable, recorded the data. And then we repeated that same process for flow rates of 3, 4.5, and 6 liters per minute. And here are the results for 5. So using the heat equation, m dot CV delta T, with our specific heat value of 4,180, we get about 29.16% of your coefficient of performance for 5. And then our results for the 6, slightly higher at 35%. And results for 4.5 drops a little bit, 26.24. And results for 3, 17.5%, all using the same calculations. So you see, as the water flow rate goes up, your performance, your coefficient of performance actually increases. And so this is the diagram, just a little visual of the states itself before we actually do the pH diagram. So state 1 is going to be right before the compressor. State 2 is going to be the compressed R134A as your working fluid, and it's going to be sent through the condenser, and then expanded from state 3 to state 4, and then evaporated through state 4 to state 1. And this is the pH diagram that I ended up with using the steam tables given. It is shifted a little to the left for some reason that I'm not sure of. And the ideal versus the real appears to be not shifted that way. I'm not entirely sure why. I think I may have misread the tables a little bit, but yeah, it's been a while since then. And that's it. Any questions?